What are you streaming?
Because they made pottery with lots of nice lines. It's a very simple name. This culture lasted archaeologically for about 1,000 years, from sort of 5,500 BCE to 4,500 BCE, so roughly 7,000 years ago. The people of the LBK were the first farmers of Central Europe, descending from farming communities that had sprung up in Anatolia, southern Greece, and were spreading north into Europe. This culture spanned from sort of northern Serbia up into Germany, France, Belgium, Netherlands. A huge swath of territory, but within that land, they were kind of confined just to riverbanks, to the loess soil, which provided them the most fertile land for their crops. These rivers really were the lifeblood of society, and it's easy to see why. These people were farming on the frontiers, the very limits of biology. They were growing crops like wheat, for example, that had evolved in much warmer climates, right? Anatolia, the Mediterranean region. And they were applying it to a new climate. They were really farming on sort of the limit of what biology and culture and technology would allow. They built long timber-framed houses and lived in villages that could get quite large. What's the largest one? A place called Vrabel in Slovakia. Archaeologists unearthed 313 longhouses and estimate the site was occupied for 200 to 300 years. So quite big villages, farming lifestyle. It sounds kind of idyllic. I think a lot of us crave this return to a simple life, crave this return to nature, but it was probably a terrible time to be alive. When they weren't farming, the people of the LBK were no strangers to conflict. Check this out. You've definitely heard of this site, probably. It's the most famous site of the LBK, maybe, the Talheim Death Pit. It's actually only about 70 kilometers from Herxheim, and dates to the same time period, the LBK. Found in 1983, archaeologists uncovered the remains of 34 people, 9 men, 7 women, and sadly 16 children, very sadly. Considering the age profile of the people here, it seems like maybe an entire community or one or two of these longhouses was just wiped out. And they were defo killed. There's signs of violence all over the bodies. This is not a plague pit or something like that. These people came to a sticky end. Another site of interest is the Austrian village of Schletz. Here, archaeologists found an LBK village that contained perhaps remains of about 12 longhouses. The village was seemingly enclosed by 2 parallel ditches, probably a fortification of some kind. And the outer ditch contained the remains of at least 67 people. Doesn't seem like they were buried, but just left out in the open, because it seems like animals were able to get at some of the bodies. There's a gnawing on the bones and disarticulation of them. Things like that. It seems like they were disturbed by an animal. Of the 22 remains that were identified as younger adults, so they put this as age 20 to 40, there's a big sex imbalance. 17 male remains, but only 5 female. Why is that? I don't know. Is it an absolutely terrible thought? Yes. In a DNA study of the remains, it doesn't seem like these people were close relatives, which is very interesting. It is very interesting. Why did these specific people end up in this pit? Was the community just large enough that a lot of people weren't close relatives, or is something else going on? We don't know. But that is very interesting, isn't it? You would think these would be very closely related people. Last site I'm going to mention before Herxheim, Kilienstaden in Germany. Here, 26 people were recovered from a death pit, also dating to the LBK, of course. What's kind of interesting and macabre about this site is that it seems a lot of the people's long bones were broken. It's basically horrible. The people of the LBK are not here to play. Is it appropriate to come up with a little rhyme when you're talking about such a horrible event? I don't know. These aren't even all the sites that show evidence of conflict during this LBK time period. I'm just listing them to make the point that the people in this time were no strangers to conflict and violence. And despite all of that, Herxheim really stands out. It's crazy. Herxheim was discovered during the construction of an industrial area in the town. And of course, the builders, the villagers, the townsfolk started to notice the just huge amount of bones that were coming out of the ground. Archaeologists came in, they found an LBK village quite large, 250 meters by 230 meters, surrounded by an enclosure. Or at least that is what they first thought. The enclosure seems to be an illusion. It's just lots of overlapping pits. What are in these pits? A huge amount of bones. Dog bones, cow bones, and lots of human bones. In all, the minimum number of people excavated was 500. But here's the kicker, here's the crazy thing. They haven't even excavated half of the pits. This is coming from just under half the pits. So the total number of people here could be much, much higher, maybe even over 1,000 people. So why were all these people here? There are some clues which might give us an idea. At first thought, you might think this is the aftermath of a battle. Maybe like some of these other LBK sites that I mentioned earlier. The aftermath of a battle that didn't go in one village's favor. But it seems like something more complex is going on. First of all, are conflicts in this time capable of marshalling 1,000 people? The settlements contain that many people, are that many people fighting at any one time? That seems like a lot for these early farming communities. Not that they just lived on their own, but 1,000 people, 500 people, that seems high. The main clue that something else a little bit more complex is going on, though, is that it seems these people were eaten. The human remains basically show identical treatment to the animal remains. They're butchered in a way which would allow somebody to get at their tasty meat. There's a lot of sort of separation of the ribs, of the long bones, things like that. There's also very careful separation of the skull caps. Check it out. This is even one of the skulls right here. You can kind of see the top of the head has been very carefully removed. This is a really common treatment of the bodies at Herxheim. That's obviously a very horrible thing to say, and I don't know how to link it to the next thought. Another interesting clue is that deposited alongside these pits, alongside the human remains, were broken pieces of pottery. All these human remains, by the way, they're totally broken. They're totally, smashed to bits, bones everywhere. There's only a couple of burials where the person is like articulated and intact. Majority of this 500 people, a vast majority of them, just fragments. That's all that's left of them, just fragments. It seems like, they're treating pottery the same way. There seems to be lots of deliberately smashed pieces of pottery in these pits. And some of them are coming from far away, based on, the study of the flint found in here, of the pottery. Some of these people may have been traveling as far as 400 or 500 kilometers to get to Herxheim. Quite a long way. Just based on the number of people, this probably isn't one event. It's hard to say for sure, but probably not one event. But it doesn't seem like a protracted thing either. Maybe these were accumulated over 50 years is an estimate. It's hard to say for sure, right? Because dating archaeological sites, there's a lot of overlap. Dating cannot be super precise, but maybe it's not one event based on the number of people, but it also doesn't seem to be going on for a very long time. This isn't a site seemingly occupied for centuries and centuries and centuries. So based on the evidence that humans seem to be treating in a systematic way, including cannibalism, based on the sheer numbers of people involved, and based on the fact that items are seemingly traveling quite far to get to Herxheim, the two hypotheses I've seen mentioned are basically that these are captives from war being brought back to Herxheim quite a long way, or that people are willingly traveling here to participate in these cannibalistic rituals. I don't know that we can ever find the kind of evidence that could settle such a debate, but this is not your average pile of human bones, right? Now, I know some of you will be rolling your eyes. Stefan Milo, back at it again with another site that I'm blaming on ritual. I know you're rolling your eyes. I can practically hear the eyes rolling. Let's not pretend that ritualistic conflict and cannibalism isn't widely documented. Of course, the most famous example being the Aztecs, who would sacrifice captives of war to their god Huitzilopochtli. I'm sure I'm saying that incorrect. Without, their belief was without these sacrifices, the sun wouldn't rise. So human society, European society, prehistoric society, very, very capable of coming up with complex rituals and ideologies that would involve a lot of, munching of your neighbors. You're going to munch your neighbors because otherwise the sun might not rise. This kind of thing is well documented. But why so much conflict? Why so many pits, many, many sites? Why is this all happening during the LBK? Can archaeology give us any other clues? The first clue to this conundrum seems to be that the LBK was patrilocal. Basically, this means that men are staying put and women are on the move. There are a lot of genetic studies and isotope studies of human remains from the LBK time period. And, when you are examining the DNA of people from an LBK village, the men are much more closely related than the women. There's a lot of evidence to support this idea. Now, that's important because remember what I said at the start. These people are living on very specific pieces of riverbank, the most fertile pieces of riverbank. The second clue is that a lot of these pits seem to be dating towards the end of the LBK period. Not as common from the start, at least the majority of them. So, the hypothesis goes like this. In the early time period of the LBK, farmers are expanding. If you're the fifth son of your father, maybe all the land in your village is being taken up by your brothers, right? But that's not a problem because you can expand along the river. There are literally no other farming communities across Central Europe at this time, just sparsely populated areas of hunter-gatherers. You're free to travel up the river. You're free to move to a different river and basically build a new community. No problemo. But after 500 years of this lifestyle, 1,000 years of this lifestyle, are these specific points along the river starting to get full? If it's the end of the LBK and you're the fifth son, now where do you expand? The next river over is full of communities. Downstream on your river, it's full of communities. Where do you go? Maybe you already had a village established, but after, a couple of centuries of farming, intensive farming, the soil just isn't what it was, and you have to move your entire village. Where do you go? So was this conflict brought about by the fact that they had a very specific lifestyle that required very specific pieces of land, and after several centuries of living like that, a lot of those pieces of land, the choice pieces of land, were taken? Something was causing a lot of conflict during this Neolithic period. This is just a hypothesis, of course. It's impossible to look back in time and examine the motivations of people, but across time, the motivations of people, we're probably fighting over the same things over and over again, aren't we? Resources, land. Maybe ideologically they had developed some sort of warrior culture, warfare culture that is kind of hard for us to see because we're still talking in the Stone Age here. I forgot to mention that. This is still the Stone Age. So a lot of the signs of warrior culture and elite behavior that we see in later periods, like the Bronze Age, maybe are just archaeologically invisible to us because they just don't have the stuff to display conflict and violence, or at least not stuff that survives archaeologically. Who knows what they were putting on wood and paintings and all of these things that are totally gone now. Whatever the cause, society at the end of this LBK time period seems to be under a lot of stress. There's a lot of conflict, maybe whole villages being absolutely wiped out, maybe people traveling hundreds of kilometers with captives to chop them up and have them for lunch. Yeah, it's really, really horrible. Don't go back in time, guys. We've literally now maybe just found the cure for diabetes. It's better now. It's better now. Do not go back to Neolithic Herxheim. This was a broadcast from the Time Travel Awareness Service.
Fucking headaches, dude. I'm getting fucking headaches from this shit. What do we call this shit? Brain freeze? Fucking hurts. Holy fuck. Oh yeah. Tell me
Hello.
more.
Last week, I made a video where I said that 10,000 years ago, sea level was rising by 70 centimeters a year when I should have said 70 centimeters a century. Slightly off there. If sea level had been rising by 70 centimeters a year in 2,000 years, all of Britain, including Ben Nevis, its highest peak, would have been entirely submerged. So, took the video down, corrected it, put it back up. My apologies to Kaylee for missing out on the timing of our collab, therefore. Do go check out Kaylee's video on a Mesolithic shell. I'll put the link below again. But it does give me the opportunity to talk about an absolute clanger of a mistake I made some time ago. This was on a video about humans and Neanderthals. Are we the same species? And I was talking about admixing. Let's hear what I said. Which means that every single instance of admixture which contributed to our modern genetic diversity involved a Neanderthal man and a Homo sapien woman. Why is that the case? So the fact that we know modern humans and Neanderthals interbred, but we don't have Neanderthal mitochondrial DNA, means that it must have been a Neanderthal man and a modern human woman. That's what I said, and it's just not true. It's just not true. That's one possible explanation, but it's almost certainly not the most likely explanation. Let's just think about this for 1 second. When this was pointed out to me, I was like, it's so obvious. So obvious. The key thing here, right, is that mitochondrial DNA is only passed down the female line. So let's imagine this scenario. You have a modern human guy and a Neanderthal mum. Okay? So in theory, their children will inherit Neanderthal mitochondrial DNA. But, what if they have sons? What if they just have sons? Their sons will have Neanderthal mitochondrial DNA, but they won't pass it on if they had children with Homo sapien females. It could just be something so simple as that. They just had sons. In reality, right, that's just an example of one. In reality, this is where it gets interesting. Admixture is way more complicated than that. It didn't just happen one time amongst one family. Otherwise, we almost certainly wouldn't have Neanderthal DNA now, right? Because it's so easy just for one family to die. It must have happened many times, many centuries, many millennia, and multiple combinations, probably every combination of interbreeding. So why, in that scenario, don't we have Neanderthal mitochondrial DNA? Well, interesting stuff might be going on. So a new study just came out. I think it came out just now, October 1st, 2025, about a mismatch in a gene, PIEZO1. This gene controls blood oxygen. Has something to do with blood oxygen.
Basically, it seems this gene is responsible for how the blood releases oxygen, or something like that. There is the potential for
Hello.
A mismatch in hybrid females between how they would release blood compared to their offspring, perhaps. There's a potential that something might be going on there, and it might cause infertility, something like that.
Which means a hybrid mother, you know, maybe that there's a pressure against that mitochondrial DNA. If it's a problem for hybrid mothers, maybe there's a selection pressure there. Even a very small one, very, very small one, over the course of millennia, could have removed Neanderthal mitochondrial DNA. It's entirely possible that there's some like mismatch between admixture, some various combinations that had fertility problems, and that's the reason for Neanderthal genes being the way they are in modern populations. That's entirely possible. Very, very cool, interesting study. Very new study, so will this turn out to be the case? Hard to say. We obviously cannot reproduce a hybrid child to test them for infertility. There's still lots of questions. But the reason I feel like I had to correct this mistake about it being only Neanderthal males and only Homo sapien females is because I think it kind of plays into this image of Neanderthals as savages, that they're roaming around taking all the women. You know, that's not necessarily the case. There are very simple explanations for why we don't have Neanderthal mitochondrial DNA. One of them being maybe just they had sons that survived. The other one being maybe there were some infertility issues for hybrid mothers. Neanderthals weren't the bad guys, and we're the good guys, you know. In fact, what's interesting is that Neanderthal Y chromosomes are much closely related to us than they are to Denisovans. This was found out in a study in like 2020, I believe. And so the explanation for that possibly is that an admixture event left the Homo sapien Y chromosome being passed down amongst Neanderthals. It's just complicated. The way the genes are now is so complicated. We're talking about so many admixture events over the course of thousands of years, some dating back hundreds of thousands of years, like in the case of the Y chromosome. They could be having only sons survive. They could be having only girls survive. There could be fertility issues between admixture. It's just not the case that the only possible explanation is that there are Neanderthal males and Homo sapien females. That's just not the case. Not the case. So the video had to come down. I'll probably still continue the tradition, the fine Stefan Milo tradition of deleting the video and hiding under a rock. But I should do this. I should issue corrections. The year was 1997. Girl power was taking the world by storm. A young Stefan Milo was dominating the Worcester tennis scene. And almost as importantly, geneticists were making a scientific breakthrough. For the first time, we had recovered ancient DNA from a fragment of a Neanderthal, a humerus belonging to Neanderthal 1, the first ever Neanderthal found way back in 1856. It's hard to overestimate the importance of that moment. For the first time ever, we had genetic material from an extinct branch of humanity, another ancient hominin other than ourselves. It would be the first of many genetic studies into this mysterious group. And we would go on to discover that they weren't extinct as such, that a part of their DNA lives within us now, that our ancestors had children with them, way back in prehistory. It truly was the start of a new chapter in the study of human evolution, a huge moment. But many of these studies on ancient Neanderthal DNA have a fundamental problem.
So there had been, I think, 18 Neanderthal genome sequenced to various degree of completeness sequenced over the past 10 years, but they've always been separated in space and in time. It's been from all over Europe and from Siberia, but like thousands of years apart. So we never had an idea of what a Neanderthal community looked like. So that's sort of why we wanted to see if we can find multiple Neanderthals from the same place.
That's Lorit Skov, a geneticist at Berkeley, down in California. As he said, all of the Neanderthals involved in these ancient DNA studies are typically separated by a huge amount of space and a huge amount of time, thousands of years. That is until Lorit's and a team of researchers published this paper right here, Genetic Insights into the Social Organization of Neanderthals. This team were able to extract DNA from 13 Neanderthals, all from the same place, all from basically the same time. I think it's the largest study of ancient Neanderthal DNA using ancient Neanderthal remains, and certainly our best shot at using genetics to understand a real Neanderthal community, real Neanderthal families. Let's talk about it. It's absolutely incredible because you're probably an archaeology nerd like me, or you're high at 4 a.m. and somehow stumbled on this video. Either way, let's dig into it. All right, first let me pull up Google Earth
Fuck
here
drugs.
and we can see where these bones came from. Southern Siberia has been a fantastic source for Neanderthal remains. It's certainly a region that they called home for thousands and thousands of years. All of the samples used in this study are from Chagiskaya and Okladnikov caves, right where Russia meets Kazakhstan and Mongolia. All these Neanderthals were from just 2 caves. Chagiskaya and Okladnikov are also very close to Denisova Cave, which will definitely come up later in this video for sure. Something really interesting is going on in how these 3 caves and 3 populations interact with each other.
This is a list of all the different Neanderthals that we sampled, that we tried to get DNA out of.
Oh, wow, that's a lot.
Yeah, and then you can also, we also tried a lot of Okladnikov individuals, but the DNA preservation there was really bad. We did 10 Okladnikovs and 17 Chagiskayas. There was only a few of the Chagiskayas where we didn't have genetic data, and a lot of the Okladnikov where we didn't have genetic data. So we tried 27, but there are more. In Chagiskaya caves, I think there's 80 or something.
I had no idea there were that many Neanderthals from that cave.
That cave is crazy. I think there's like hundreds of thousands of bones and tool pieces. You can actually see all the samples here in this figure.
Well,
the
they are
supplementary
really
of my paper.
close in proximity and all seem to roughly come from like one sedimentary layer.
Yeah, exactly.
Wow.
And it's only the gray part. This is the cave seen from above.
Yeah.
It's only the gray part that's been excavated. So it's like a third of the cave that has been excavated yet, yielding 80 Neanderthals. So you know that there's a possibility that there will be even more Neanderthals found in this cave. And the excavations are still going on.
Before I spoke to Laritz, I honestly had no idea that archaeologists had recovered so many Neanderthals from this cave. I mean, just look at the IDs of some of these fossil remains. Chagiskaya 60, Chagiskaya 63. There's a lot of Neanderthals here. It really makes you wonder what happened in those caves. How did they accumulate so many remains? Was it perhaps a particularly good spot for Neanderthals? So they're just living there for a long time and these bones are just naturally accumulating generation after generation? Was there some sort of disaster that trapped them all in there? Were they deliberately depositing the dead? Maybe even brought in by predators? The mind boggles. There's a lot of Neanderthals in those 2 caves. I really wanted to ask Laritz, from a genetics point of view, what's the advantage of having so many samples?
The more people you have, the more you can talk about recent time of the ancestors of those people. So for instance, yeah, if I have your genome or my genome, it's the same information I get like 200,000 years ago, more or less.
Yeah.
So it doesn't add so much, but where it really adds is the resolution close to where these individuals lived, which is just what we want to get at with studying a Neanderthal community. We want to know how were they related. We don't want to know what the average Neanderthal population size was 100 years before they lived or something like that.
I'm sure this is a simplification, but basically, studying one person's or one Neanderthal's genome can give you a good overview of their evolution, but it can't give you a lot of detail about the community that they lived in. Who were they related to? How did this community interact with other communities? Stuff like that. But with this increased sample size, we can start to ask those kind of questions.
Okay, so we have the ability, when we have all these genomes, to discuss relationships between Neanderthals. So what is the relationship between the
too late.
Neanderthals in Chagiskaya Cave? Are they from a big community? Are they closely related? How
No,
do
I
all
didn't.
these
It wasn't too
Neanderthals
late. I
fit
lied.
together?
Yeah, that's I'm glad you asked. So, so what we can say about this community is that it's small and has been small for quite a while. So it's something like 10 to 20 individuals or something like that. And it's been like this for a couple of generations.
This result, that this Neanderthal community was quite small and had been that way for several generations, really adds to a growing body of evidence, particularly genetic evidence, that suggests that Neanderthals' communities were pretty small, pretty spread out, pretty inbred, at least compared to anatomically modern humans. This result has really interesting implications when we think about why the Neanderthals aren't around anymore, and why do modern people, like me and you, have such a small percentage of Neanderthal DNA. There are so many possible reasons for their demise. Natural disasters, competition with Homo sapiens, assimilation into Homo sapiens, maybe we absorbed them into their community, into our communities, and just chipped away at their population. Whatever the cause of their ultimate demise, if their populations were very small, very spread out perhaps, very inbred, yeah, they might have been very vulnerable, very susceptible to change. Interesting to think about. Still, just because this population was small doesn't mean it was totally cut off. What's so great about this study is that we can see into Neanderthal families, see into Neanderthal communities.
So in terms of relationships, we have some of them who are related to each other, but also some who are not related to anyone else. So you can see that some of them are related, and we found the first ever father-daughter, Neanderthal father-daughter pair, which is like these two individuals here. And then we find two individuals that are second degree related, and some that share a heteroplasmy. It's called, so they share like part of their maternally inherited DNA, meaning that their mothers were closely related.
So D, E, and C all share mothers that were closely related.
Yeah. Or like something like they could have shared a grandmother or something like that.
Oh, so really closely related then. They're cousins, basically, probably.
Yeah, it's actually hard because the father here, Turkish guy number D, looks to be very similar to E, and we're actually not sure if it's the same individual or if they are first degree related. And the reason we can't tell is because Turkish guy eats a tooth that has been eaten by a hyena. So it's heavily contaminated with hyena DNA. So it looks like, a bit Neanderthal, a bit human contamination, and a bit of hyena contamination as well.
Do you ever hear something that just makes your brain pause for a second? D could be E, but it's hard to tell for sure because E was eaten by a hyena. I mean, I feel bad for the guy. I feel bad for the guy. But that is a fun sentence to say. That is a really fun sentence to say. How can people not love learning about prehistory when you get to say sentences like that?
It's so hard when you just say something like that. My mind just starts wondering.
Yeah, like is that how they died? Were they all eaten by hyenas, or
Well, that's why I'm wondering why why so many Neanderthals in that cave?
Exactly, and I don't know.
A and L have a second degree relationship. There's quite a lot of things that could be, but it's something like uncle, niece,
Hey, Al.
aunt, nephew, something like that.
Oh,
Close
there it is.
relatives
Fuck.
still.
And just to give you an idea of like how much is happening, like there's been a new method after we published this paper that can sort of that
Let's
is
do
a
it
bit
again.
better at estimating relationships, can do it more accurately. And that method it finds all these relationships, but also suggests that H and L might be sort of closely related, as in third degree related.
I just love being able to look at this super simple Neanderthal family tree. It's so humanizing to see like a Neanderthal father and daughter. As a dad to a daughter myself, I love it. I love it. It's so humanizing. Really brings the past to life. It's cool. It's super cool.
I mean, I suppose, in a way, if they're from a very small community and it's been that way for several generations, then that's what we would expect. Maybe the outliers are the B and I and F and G and J and K. Like, why aren't these people more closely related?
Yeah, exactly. Like, exactly. Like, if you have a small community, then you will just be the second or third cousin of someone.
Maybe the outliers are this B and I and F, G, J, and K. Who are these people? Why aren't they more closely related to the others? Where did they come from? To understand how genetics can help us tease apart community
Serious
relations,
basic user.
we need a tiny bit of context, a teeny tiny bit of context. You inherit your genome equally from your parents, half from your mum, half from your dad. But there are some parts of your genome, of your DNA, that come exclusively from one parent. Men inherit their Y chromosomes from their father, so that provides an exclusive genetic record of the males in your family tree. Your mitochondrial DNA is passed down by a mother to her children and will only be passed down by her daughters. Except for maybe in extremely rare circumstances that we're not quite sure, like a fraction of a percentage chance it might be passed down by fathers in some extremely rare scenarios that maybe exist, maybe don't, but seemingly 99.99999% of the time, your mitochondrial DNA is passed down by a mother and her daughters. So this provides an exclusive record of women in your family history. This allows us to compare the Y chromosome and mitochondrial DNA within these Neanderthals and get a sense of how evolution and society is affecting men and women differently. When they made this comparison, Loritz and this team made a really interesting discovery.
An important factor here is that it's not an isolated population. It's not an isolated community. It is a very small community that is exchanging individuals with other communities. Because if you just have one community of 10 to 20 individuals and that never exchanges with other communities, it goes extinct. That's sort of the starting point. But then when we looked at the data, it turns out that the mitochondrial diversity is 10 times higher than the Y chromosome. So a factor of 10. So like a clearly significant difference.
Yeah.
And so the question is, how can that be? One way you can think about it is that if you have all these different communities and women are moving between these communities and they are the one passing down the mitochondria, then you could get a mitochondria that's in a community that looks very different from the other ones because it came from somewhere else. So that will give you a lot of mitochondrial diversity, but the Y chromosome diversity will still be low.
According to the results from Chagaskaya Cave, then, there is some mechanism by which Neanderthal women are moving around this society, moving around different groups. So much so that their mitochondrial DNA is 10 times more diverse than the Y chromosomes. Men are seemingly staying put, women are seemingly moving.
This pattern of female movement is actually quite common, both in modern humans, in a lot of human societies. Of course, some societies do other things, and you also see similar patterns in chimpanzee, for instance. And you see similar patterns in gorillas, but not in orangutans. So,
Oh, really?
yeah. So whatever these Neanderthals are doing is actually not so different from humans.
So far, we've only discussed the Neanderthals from Chagaskaya Cave. But when we look at the two Neanderthals that DNA was extracted from at Okladnikov Cave, again we see this pattern of female movement.
So there are two individuals there that carry the same mitochondria. So again, shared mother. They don't share heteroplasmy, so we can't say it's that close to each other. But they do have an identical copy of mitochondria.
Chagaskaya B shares the exact same mitochondrial DNA as Okladnikov A. We can't really look into much detail and say how closely they were related to each other, but they were so closely related on their female line that their mitochondrial DNA did not have a single mutation between them. They had exactly the same mitochondrial DNA.
So all we can say is that they lived within a couple of thousand years of each other.
It was recent enough that there was not a single mutation yet in the mitochondrial DNA.
Exactly.
Interesting.
It's really fascinating to see this pattern of female movement in this community. And imagine, speculate, how we got our Neanderthal DNA. Like, is your 2% Neanderthal DNA from your great however many times Neanderthal grandma? It's certainly possible. No modern human has the mitochondrial DNA of a Neanderthal, but that doesn't mean we're not related to them on our female side, the female side of our family history. Let me draw a hypothetical scenario quickly, because this is kind of fun to illustrate. Let me get a paper or something. Excuse me, chaps. Let's say, hypothetically, you have a Neanderthal woman who joins a community with Homo sapiens, sexy Homo sapiens. And let's say, hypothetically, they only have sons. Or maybe only sons survive into adulthood. Something like that. If these sons continue to have children with that community, with Homo sapiens women in that community, the grandchildren of this Neanderthal woman, Neanderthal man, would not have this mitochondrial connection to this Neanderthal woman anymore, because they only had sons. That mitochondrial connection is broken. But that wouldn't mean that the children of these boys didn't have a Neanderthal grandma.
Hello.
You could happen to have children that's the other side. I really had to clear that up because in an old video of mine, a now deleted video, I said that because no one had Neanderthal mitochondrial DNA, it means that we're related to Neanderthals on our male side, that we had a Neanderthal granddad. That is something that's often said online, but it's wrong. It's an oversimplification. We could have Neanderthals on our male or female line. We don't have Neanderthal Y chromosomes either. However, Neanderthals and Homo sapiens interacted with each other. They weren't alone in the vast expanses of Asia. There were also the Denisovans. And again, this study has some really interesting things to say about how these groups interacted. Chagiskaya and Okladnikov Cave are very close to Denisova Cave. In fact, Okladnikov actually sits on the same river as Denisova. It's in the same valley, along the river Anui, I think it's pronounced. Even Chagiskaya is just about 100 kilometers away, over a mountain valley, over the other side of a valley, but still just 100 kilometers away. These caves are just like 3 days walk from each other maybe. Not far at all. For those that don't know, Denisova Cave was made famous in 2010 when geneticists tested what they thought was a Neanderthal finger bone, pinky bone, but it turned out that it belonged to a group that was closely related to Neanderthals and Homo sapiens, but also quite genetically distinct. And we now call this group Denisovans, after Denisova Cave. It really was a surprising result, totally changed our view of human evolution. All these three groups are all mixing with each other, having families like this. It's really interesting. It's really cool. We know that Denisovans and Neanderthals in this region of southern Siberia are interacting with each other because in Denisova Cave we found the remains of a child that had a Denisovan father and a Neanderthal mother.
the mom's Neanderthal, and so she passes on the mitochondria because of the female, and that mitochondria is very similar to the Czechoslovakia mitochondria.
Oh, really? So the mother of that Neanderthal Denisovan hybrid was relatively closely related to these individuals at
Exactly, yeah. And relatively is the key.
So again, we see this pattern of female movement. 3 caves connected to each other, again, on their female line. You would think that the Neanderthals at Chagaskaya and Okladnikov also had a fair amount of Denisovan admixture then, as they're living in this same region.
Yeah.
Did this group have much Denisovan admixture in
No,
their
so
DNA?
that's even what's even more interesting. If we take the radiocarbon dating and the dating of sediments in Chagaskaya Cave, we think it's been occupied between 50 and 60,000 years ago. And if we look at sediment DNA from Denisova Cave, there are also Denisovans present around this time, 50 to 60,000 years ago. So they're supposedly both around and close to each other, but we don't find evidence, a lot of Denisova ancestry in our Neanderthals. There's not a lot of evidence of recent mixing of these two populations.
It's a bit of a puzzler. It's a bit of a head scratcher, isn't it? We know that Neanderthals and Denisovans are in the region at the same time because we've got that first generation hybrid who had a Neanderthal mother, relatively closely related to these other groups. And yet the other Neanderthals at this cave seemingly don't have
Fuck all y'all. I'm going to the fucking bathroom. Stream's fucking over, my man. I'm fucking done. Dunzo.